fairly well. We're going to work in our density lab today, which is kind of fun. You guys will be here in about 10 minutes. So let's do a couple of reviews and work on sig fig practices with our addition, subtraction, multiplication, and division. So tell me how you started to solve this problem, Sarah. The mass of a regular solid A is 152.2 grams. Its length and width are 3 centimeters each. Its height is 2 centimeters. What is the formula for the density of the rectangular prism or solid? Tell me how you started it.
For that one, I looked at the mass and multiplied it by, or no, sorry, not multiplied by, yeah, mass and volume.
And that's density. That is our density formula, right? So I didn't teach it to you because I would expect you to probably know that. Picked it up from one of your reading guides. So our mass in this case is what? Keep going.
It was 152.2
grams, right? So we know mass is a reading, grams is a reading of mass, is a unit for mass. So right here, this is just one part of the problem. We now have to kind of do a second calculation to prepare the volume to get the density. So what are we going to do for volume? Audrey. Trying to shout up names I know here. Audrey, how do I get volume? So 3 centimeters times 3 centimeters times 2 centimeters, right? So 3 times 3 is 9 times 2, 18. So 18 centimeters. The problem that most people have is that you want to go to sig figs, correct sig figs every single baby step of the problem. It's sometimes wrong to do every baby step because you end up rounding 3 times in a problem. In the end, it's like super rounded for the final answer. You only ever really want to do your sig figs at the very end to make sure you don't round 3 times and then mistakenly have a 2 rounded up answer. So here I'm going to keep 18. If I was making this my final answer, what would I need to record it as? How many sig figs are here, here, and here? 1. So I need to record that to 1 sig fig. How do I record that to 1 sig fig if I wanted to? I'd have to stop, okay, so I need 1 sig fig. I start from the left. I have to record the 1. The second number needs to be adjusted. So if I wanted to round this, I ignore the 8. I need to take it. Does it influence the 1? So I round it to 2. 20. 20 centimeters. It's close to 18 centimeters, but it's to 1 sig fig. But I'm not doing that because this is not my final answer. I don't care about the volume right now. I care about the density. So I'm taking the 18, placing it over here. So now, at this point, I'm going to get my final answer, right? How many sig figs should it be reported to? 2, because this is the one that's 2 sig figs. That's the limiting. This one's got 4. So I'm going to take 152 over 152.2 over 18. What is it? 8.45 grams per centimeter, right? This needs to be rounded to what? 8.5, good. 8.5 because you need 2 sig figs, so you're recording from the left, you're counting, there's 1 right there, there's 1 right there, but the 5 doesn't influence the 4, so it goes up to 8.5 grams per centimeter. Final answer, 8.5 centimeters. So it's just you have some more background noise going on in your head because you have to consider these significant figures and when do I really need to count them and stuff. Okay, thumbs up, you get number 1? We're good here? Okay, so that's an easier one because we have a prism and we have kind of length times width times height thing that we're kind of used to. This one's a little different. We have a pebble, I think, a rock, and the rock is 45 grams. The volume of the rock is calculated using water displacement. Who's ever used water displacement to get the volume of something? Okay, so it was probably accidentally have done that in the bathtub. You get in the bathtub, water displacement, water goes out of the bathtub, okay? So you have a large volume. So anytime that you insert water, insert something into water, the water should increase. Okay, back with me. Shh, thank you. Okay, so tell me, what did you do to get the density of this one? Density is mass over volume. We know the mass. What is it? 45 grams. The more you give me, the more work you have time for homework later. Okay. After putting the solid in, the water level rose to 75. What was the volume of that rock? Right, 15. So 75 minus 60, so 15 milliliters. And what is that? You can do that in your head. 3 grams per milliliter. Final answer? No. How many stick figs do I need? 2. So 3.0. You're like exactly sure it's 3 for estimate, or we're more accurate than just 3. We're 3.0. So super awesome. All right. So we got density. We're gonna do a lab with it here shortly. Let's look at your homework. Oh, yeah, and I'll go back to this other stuff in a second. That's not what I want. Take a second and look at, can you guys see that okay? I can maybe expand it a little bit. I only did 3, 4, and 5 because those are the ones that I feel like were the ones you can make a mistake on. The other ones, maybe not necessarily. So, take 5 minutes, check yourself, ask a neighbor, ask me. I'll be back. I typed this up this morning about 5:45 for you guys. So if I missed a squared, because subscripts and superscripts are sometimes an extra step, that should be correct on I, 10 centimeters squared. So the rounding part, I think most people were having problems with, a couple of the ones there, and then the answers for the additions and subtraction, multiplication, division. If you have a question and you don't understand how I got whatever I did, please ask and I'll do it on the board. I'm trying to force you people to ask questions. Yeah.
Can you do letter J?
J from number 4. Okay. J is J said 120 kilometers squared divided by 80 or 8.56 kilometers. So you already know that kilometers squared divided by kilometers is going to be kilometers, so that's going to be our answer's unit. But then when you're dividing, you count sig figs. So there's 2 sig figs here, 1, 2, the 0. I'm sorry, from absent, decimals absent. You start from the Atlantic. Ignore the 0, 2, and 1. Those are the 2 sig figs. This one has 3 sig figs because decimal's present. Start from Pacific, count, count, count. So 2 sig figs win. So in the end, you can only have two sig figs. 180 or 120 divided by 8.56 is like 14.08 something, 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 I believe. So your 14 is going to be your two sig figs, because when you round anything, you always start from the left side and go to the right. So 1, 2, those are the two sig figs. The 0 does not influence the 14 or the 4, so it just sticks as 14. Another question.
Is it okay if you put like some in the scientific notation?
Yeah, that's totally fine. It's a tool to use whenever you need to. Okay, I'm gonna, yeah.
For sig figs, can you have like, for that one, did you have a formula in it, or did it have to be zero?
It had to be 2 only because anytime you have a calculation, you have to consider the accuracy of their measurements. This one is kind of accurate. This one's more accurate, but this one's limiting our accuracy to our final call. So that's why we have to transfer 2 sig figs into our final answer.
So when are you supposed to like round numbers up?
So basically anytime you have a calculation, you're just going to straight up calculate it. And then you consider, is it added and subtracted? And if it is, you look at the decimals of the things that you're adding and subtracting. And you must round your final answer to correspond with the number of decimals that was the weakest in your calculation. Same thing for multiplication and division. Calculate straight up, and then you go back and consider how accurate were my things. They're only accurate to 2 sig figs, so my final answer must be rounded. You're basically rounding every single time because you have to round to sig figs according to your question. Yeah.
We could do C for 4.
C for 4. Yeah. And those of you who are good, maybe the person next to you has a question, you can ask them. C for 4. 13, let me take this out. 8.3 times 10 to the 4th centimeters cubed divided by 3.8 times 10 to the 2nd centimeters. So centimeters cubed divided by centimeters is going to leave us with centimeters squared, and then 8.13 times 10 to the 4th. Oh, problem that a lot of people have is whenever you're putting in your calculator, you need to put parentheses for numerator and denominator sometimes, specifically when you're using scientific notation. The calculator does not know what this times 10 to the 4th is going with. So you need to group that and then group that. What you probably should see is that 8.13 divided by 3.8 is about like 2.5 maybe. And then 10 to the 4th divided by 10 to the 2nd should be what? What happens when you divide? Yeah, it should be 10 to the 2nd. So it's about 2.5. That's what the final C I'm for. Oh. Oh, because I was like, I was like, what am I doing? Okay. So 2. Oh, final. $213.947 was what I got when I divided, but this needs to be recorded to either 3 sig figs or 2 sig figs. So the weakest link is our 2 sig figs. So this is rounded by taking from the left side over 1, 2. Those 2 must stay. The last one needs to be, considered. Does it cause rounding? No. So 3 doesn't cause a 1 to round. So it's 210 because we still have to have a magnitude to scale the number. So we can't just write 21. So it must be rounded. Okay. Write down what you need to. Ask me more questions. I'm available for tutoring. Yeah.
5C.
5C. That one was rounded to 2 sig figs. So what we had was you had to record 2 sig figs, but you couldn't just write 60, but you couldn't write 600 because 600 has how many sig figs? 1. So 600 point is 3, but just straight 600 is only 1. So you just use your tools, which is scientific notation, to adjust it to write it in a different way. So you just morph it.
Will the 0.5 not round to 4?
So that's called double rounding. If you take the 0.5 and round the 4, then round the 4 up to 5, and then take the 5 and round that up to 61 or 6.1, it's called double rounding. You can't do that. You only look at the next one, not 2 over. Maybe another question? Yeah?
Can we do H for 4?
Mm-hmm. H. So whenever you take your 2 quantities and you multiply them on that one, you get, I'm not saying that what's on you first see that the 4.5 times 10 to the 5th kilometers has how many sig figs? How many sig figs? 2 sig figs, thank you. And then you see that when you have the 3.00 times 10 to the third, kilometers has how many? 3 sig figs. So you know in the end you're only going to have 2 sig figs. So when you multiply 4.5 times 3.0, and then these two as well, you get just H. Yeah. 1.35 times 10 to the 9th kilometers squared, because you have kilometers and kilometers. So this needs to be rounded, 1.35 needs to be rounded to 2 sig figs. So you count from left to the right. 1 and the 3 must stay. The 5 is considered because it influences the 3 up. So 1.4 times 10 to the 9th kilometers squared should be our final. Okay, last question. Yeah.
We'll do 4K.
4K. Yeah. 4. When you have little numbers, little. .005600 millimeters cubed divided by 0.200 millimeters squared. You should see millimeters cubed and millimeters squared makes millimeters straight. No, just to the first. When you divide these, you do have to count sig figs. So how many sig figs in the first one? Everybody? 4. Because you have decimal present, you can ignore 4. This one has 3. So you only consider, and you only have 3 sig figs. Whenever you get your final kind of first calculated answer, it's 0.0280. Yeah, and that's 3 sig figs. So it's just that. I don't believe there's actually any rounding needed on that one, because that has 3 sig figs. I want to take the rest of the questions later, because I want to make sure that we do have to move on in class a little bit. So those of you who have more questions, see me after class. see me after school, or email me. Okay, so there was one thing I didn't mention yesterday. You can write this anywhere. Was the additions to the metric system that we are going to be using. So we know the metric system. What was our silly way of remembering it? King Henry died by drinking chocolate milk. Okay, and we know how to do the decimal roots. We also have a couple on either end, and I just need you to know what they are, and we will use them more tomorrow. Okay, so right in front of the K, wherever you had your King Henry died by drinking chocolate milk, right in front of it, 2 decimal places and an M. Okay, that means that there are zeros, or there are placeholders between the K and the M. So if you look at it, the M, which is mega is 1,000 times greater than kilo. Just like kilo is 2 places away from base, that's why like a meter and a kilometer, they're 1,000 apart, size difference, scale difference as well. So a kilometer is 1,000 times greater than a meter. The other ones here on the other side are weird. Okay, so M is mega. What is M right here? Little m. Milli, right? Milli is 2 spaces away from this funny U. It's a U with a tail in the front, and it's called micro, like a micrometer, okay, or a micrometer, however you want to say it. So a millimeter is 1,000 times greater, because it's 3 away from. It's 1,000 times greater than a micrometer. This N is nano, and the P is pico. These are other prefixes that you just need to be aware of. And these dots here, there are prefixes for every single spot here, but we don't need to know them all. So these 2 dots are specific prefixes. Those are these, and these. So whenever you're thinking about it, we're actually set up a number line, but this nano is like 10 to the negative 9. So nano and 9, I think, is actually really easy to remember. We'll talk about that more tomorrow. I just want to give you a heads up. Okay? So mega, micro, nano, pico. Okay. This I might do in a second. I already went through this. Okay. Let me do one part of the yellow sheet, the orange sheet that you guys have. I just want to make sure that when we are going to our lab today, you're using figures. So when you turn, make sure everybody has it. Turn to the back on model 3. Model 3, okay? You'll see this, the ruler scheme again. We've seen this before. You'll see that there are valid measurements and invalid measurements. Remember that, and this is actually kind of a quick reminder before we go to our lab. Remember that when you have a scale, you have to look at it, get what you know, and then estimate one past that, one decimal point, one placeholder past that. So on part C, or on, let's say on part B, ruler B, what do you definitely know about that, whatever that object is? What's the length you definitely know? Ruler B. Okay, it's 3 centimeters, and then you must estimate 3.1 or 3.2 centimeters. So the people over there on the invalid measurements, 3 is a lie. I mean, it's true, but it's not enough. And 3.25, 3.20, those are going to be invalid because we just don't move that far. And then on ruler C, we know that it's 3.2, and then you must estimate 3.21, 3.22, or 3.33, or so forth. So just make sure that you're using your estimation skills there, because sig figs you're going to be using them pretty much from now on and specifically in your lab. Okay? So pull out a piece of paper for your lab. I'll tell you exactly what you're doing. You're going to set you free. Leave your homework on your desk so I can come back around. Back when I saw a rough draft, I want to see more. Okay? So this is your first kind of teamwork lab here, because you guys can kind of dividing and conquering as much as you need to, and then collaborating. So this lab is called a density lab, and that basically means that your lab looks like this. It's kind of not very filled out, okay? Those sort of procedures kind of tells your goal, but how you do everything on this one is up to you. You can ask me any questions that you. And this is the first one I like to do, just because this is a pretty easy lab. You have 8 objects. I'm going to turn this way, I'll show you. You have 8 random objects, with 7 8 random objects, made from different materials. You can probably feel them and tell me, one's lighter than the other, but I want you to calculate the density of each of your objects using what you know the density formula is, in whatever way you need to. I have given you tools, I have given you rulers, and underneath your cabinets you have different size graduated cylinders. The graduated cylinders have different graduations on them now, okay? So if you're using one, you might reward it to 2 decimals. If you use one like this one, I'll have a couple of these big last ones I'll kind of just monitor because these are costly. You'll notice that, what's the reading on this? What can you measure? Okay, so it goes by hundreds, but what's in the middle? 10. So if something was at the line right above 100, what would that be? 110? Exactly? Isn't the reading 110? If it's at that line, it's 110. What must you do? Estimate. So 110, maybe it's 111. Maybe it's just a hair above that, so you have to say 111. So you've got to use your estimation skills on this. And the other graduated cylinders are all underneath your guys' cap. You also have a lab notebook under there. You're going to have to flip upon the one that says density of a solid lab inquiry. Okay? After that, you can send the board. After you get all your calculations, you show me all your calculations. You need to organize your data in a data table of your choice. It needs to just be organized so that I can understand it. And then you're going to set up your little pieces from least to most dense and label it so I know. Take a picture of it, send it to my email. It requires you to know my email address. And then I want you guys to graph your results as the final, okay? 1 graph per group, 4 or 3, however many labs or people in your lab, 3 papers per group, so I want everybody to have their papers, their own math, but 1 graph. Deal? Good? Go to your lab station. No goggles required for this one. Pull out your lab and pull out your materials.
Did you go to the same group?
Same groups as yesterday, yes. And I think I'm missing 2 people. I'm going to have somebody adopt Kendall after we get things back. And then we'll go from there.